Okay, in this video we're going to talk about some of the most basic and fundamental constructs in computer programming. We're discussing Python 3, and let's open up a terminal. And so far we've learned that you can create a text file that has a .py extension and execute any Python code in that file using the Python 3 command from the Linux terminal, Python 3. Okay, so let me change directories to my desktop so you can see me create a file, nano hello.py. So I'm going to make a file and say print, which is a function it's a built-in function in Python 3, and I'm going to say hello. Let me save this file, and I can now run Python 3 and then hello.py, and we see it executed all of the Python code in that file. Alright. So Python 3 also has an interactive mode where you don't actually need a file. You can execute statements or lines of code in Python one at a time. Okay. To do that, you just type in Python 3 and don't specify a file name. Okay. So it tells you the version you're using, and then this is the Python 3 prompt. You have 3 greater than signs right next to each other. That lets you know that you're in Python 3 and not some other type of interpreter or at the Linux command line. All right. So I can type in the same code we just typed, hello, and the output prints out just like that. Okay. So this is going to be helpful as we go forward. We're going to try out a bunch of stuff as we discuss these new constructs, and we're going to try them out inside of the Python 3 interactive mode, okay, the interactive shell inside of Python 3. So we'll test out certain lines of code in here and see what the result is. Now all of this we could do by creating a file and executing the file as well. All right, but this, when you're trying things out and testing things, this is very handy to be able to just open up Python 3 interactive mode. Okay, so when we're talking about computer science and computer programming, there are sort of 2 fundamental constructs that are interrelated, but slightly different. Okay, there's a concept of a programmatic statement, and let's go ahead and open up Atom, and so we can take a few notes here. Okay, so let me save this file to desktop. Okay. So first, let's paste in Python 3 interactive mode. Okay, so you use the Python 3 command with no arguments. All right, and what we want to talk about next is a programmatic statement. Okay, so when we are typing data into a Python file or typing in a line of code to be executed in the Python 3 shell, we are usually writing programmatic statements. We're either writing programmatic statements or we're writing expressions. Okay, so a programmatic statement is a syntactically meaningful line of code that performs some action, but the key thing is it does not return a value. Okay, an expression is the same thing. It's a syntactically correct collection of literal and or variable data, and we'll go into what that means. And those are the operands. So the data is your operand, and then operators, like in basic mathematics or arithmetic, you have the addition operator, subtraction operator. It is the symbol that goes in between the operands to tell you what action to perform. All right, you have grouping symbols, function calls, etc. But the main thing is that expressions can be evaluated to a single value. Okay, a statement does not evaluate to a value. An expression does. Okay, so let's look at one of the most common and most basic types of statements in computer science, and that's the assignment statement. This is where we assign a value to a variable. Okay, so you have an identifier, then you have the assignment operator, which is the equals sign, and then you have an expression. Okay, so what is an identifier? Okay, an identifier is just a variable name. It can be the name of a variable, a name of a function, or a name of a class, or some other construct within computer science, okay? But it's just used to identify something. It's basically the name or the label, okay? So it's a syntactic label used to identify various constructs within a program, such as variables, functions, or classes, okay? Now this part's important. How can you name these things? How can you construct these identifiers? They may contain upper or lowercase letters, they can contain underscores or numerals, but they may not begin with a numeral. Okay, so these are valid. Name 1. This is invalid. One name. Okay, you can have an underscore there, right? Now, this would be fine because it starts with a letter, or even if it starts with an underscore, but it just cannot start with a numeral. Right? So here in our assignment statement, we have an identifier, so something like this, and then a space. You don't technically have to have the space, but you can. An equal sign, and then another space. You don't technically have to have the space, but it makes your code look cleaner and easier to read. And then you have some expression that you want to store in this variable. Okay, so this is called an assignment statement because you're assigning a value to a variable. Okay, so in terms of what the computer is doing behind the scenes, your computer has memory, which is a way to keep track of ones and zeros, right? We talked about binary ones and zeros and switches and how memory stores information. Okay, so basically what happens here is you're naming some value, and in memory this value gets stored, and this identifier is associated with some address location in memory. So whenever I type this identifier, the computer looks at a specific memory location and then gets the data at that memory location. Okay, so let's do some examples here. We'll open up Python 3 in interactive mode, and we can say we were counting something. We had several customers, and we want to know how many customers we had that day, and we need some variable. Okay, so the variable identifier is NUM. That's the number, and we could say number of customers, right? We can add an underscore in there, but this is all still one variable name. And I could say the number of customers is 0. Now this is a statement. Notice this whole thing did not return a value. What happened? We created an identifier. We set that identifier equal to some value, some expression. This is the simplest form of an expression. It is just one piece of data. Okay, one piece of data can be an expression, and it evaluates to one single value. All right. So I can print this out. This is the number of customers that we have today. And so you might have this variable at the beginning of the day, and as you go through and make different transactions, you have number customers equals whatever the number of customers was before plus 1. So every time we make a sale, we would run this statement. Number of customers equals whatever it did before plus 1. This whole thing is an expression. Okay? So at this point in the code, number of customers, our variable, equals 0. At this line, we're saying, okay, I want to assign a new value to this variable. So here's the identifier of the variable, and I want to set that equal to whatever this variable currently equals, which is 0, and then add 1 to that. So 0 plus 1. So number of customers now should equal 1. Okay. Now let's say I make another transaction. I do the same thing. Number of customers. Now I need to take whatever number of customers was before and add 1 to it. This is called incrementing. It's a very common thing to do in computer science, to increment a variable. Oops. And we can print out number of customers. It's 2. So every time I do this, I'm incrementing the variable. Okay, so this is a very common thing to do in computer science. There's also a shortcut to do that. You can say number of customers plus equals 1. This plus equals means you're setting number of customers equal to whatever it was before plus 1. Okay, so this line here, this statement, is the same as this statement. Okay, assign a new value to number of customers, and that new value is whatever it was before plus 1. All right, that's the same thing that this one is saying. Assign a new value to the variable called number customers, NUM underscore CUST, and we want that new value to be whatever is stored in there now plus 1. So plus equals is very common. It means increment. You can also decrement. I can say minus equals 1, and that will remove 1 from the variable. Okay? Alright, so that's a basic assignment statement. You're creating an identifier, which is basically the name of the variable, and then you are setting it equal to a value. So in memory, in the computer's actual memory, the identifier is associated with the memory address, and then whenever you use that identifier, it looks up that memory address and looks at the value stored in there, and it returns that to your program, and then you can use it. Okay, so with identifiers, since you can't use spaces, let me add that specifically. Since you can't use spaces, there's some common ways to define these identifiers, because you might have identifiers that have multiple words. Like for instance, in this last example we used, our variable was 2 words. It was number of customers, right? Number customers. So to designate the separation between words, I used an underscore. There are several different ways you can do this. There are some common ones. These are the most common ones. Okay, so we have snake case style. So between each word you have an underscore. That's what we used here. That's common in Python. Snake case underscore style, right? This is kebab case style. It looks like a shish kebab because there's a little hyphen. It looks like it's skewered all the way through. All right, so that's kebab's case. You use hyphens. Kebab case is not allowed in Python. Okay, but in other programming languages it's common, and you can see this. It's common for CSS class names, file naming, and that sort of thing. All right, but in Python for identifiers you cannot have hyphens. You can, however, have the underscores. All right. Okay. Camel case is another common style. It starts, the first word is lowercase, and every word after that is capitalized. So camel case style. And then Pascal case style, I believe, comes from the Pascal programming language, but it's just like camel case except the first word is capitalized as well. Okay, so these are common multi-word identifier styles. It's best to kind of pick one and use it regularly. In Python, this is the most common. There are some style guides that give you examples of how you might want to code, but it's not required. These style guides suggest using this mostly. So I go back and forth between this and camel case a lot of the times, because lots of other programming languages, camel case is the preferred style. So you'll see me go back and forth. All right. So we've got this idea of a statement. A statement does not return a value. So the most common statement in computer science is probably the assignment statement. We have an identifier to create a variable, the equal sign, and some expression. That expression has to evaluate to a value. All right. And we looked at what an expression is. It's a collection of literal or variable data. Okay, what is literal data? Actually, let's bring this on down. So a syntactically correct collection of literal or variable data, right? These are the operands. Okay, so let's make a new section under here called Operands. And you can think of operands as just data, right? We've seen operands tons of times. 5 plus 5 is basic arithmetic, 5 plus 6. The 5 and the 6 are operands. The plus sign is the operator, right? This is basic arithmetic. Okay, so operands in computer science are similar. It's basically just the data. Now, literal data is data that you've actually typed into your computer program. It's hard-coded. So you've directly typed it into your program. Okay, so data that is literally directly typed, hard-coded into your program. So if I say name equals Bob, this string data here is literal data. I have literally typed in the value that I want to be stored in this variable. This part is the literal. This is not the literal. This is a variable name. This is an identifier. Literal data is actually typing in data, a core data type, into a computer program. Okay, that's literal data. I can also say print Alice. This again is literal data. There's no variable involved in this case. Okay, so I'm just printing out this literal thing that I have typed into my computer program. All right, that's literal data. The other common type of data we use, or operand in an expression, is variable data. Okay, and this is data that has been stored in a variable via some assignment statement usually. The value to assign to a variable can be obtained numerous different ways, but in general it is always the result of evaluating an expression to a single value. Okay, so expressions we see are a collection of a lot of different things. You have the operands, operators, grouping symbols, just like in basic arithmetic and mathematics. We also have function calls. Function calls can return values, and other expressions even that can be evaluated. But fundamentally, they can all be evaluated to a single value. If it's syntactically correct, then you can execute that line of code, and it will evaluate to a single value. All right, so let's look in the terminal and look at some examples. Let's say 5 times 6 plus 3. This is an expression. We have two operands here, 5 and 6, and in between them we have an operator. So this will be evaluated first, and that'll be 30, and then we have this whole thing, which will be 30. We have an operand, an operator, and an operand. So this is going to be 30 plus 3. Alright, so that's going to be 33. Expressions can get as long and as complicated as you want. They can get enormously complicated. But to simplify some of that, you can have grouping symbols. So 4 times, and then whatever is inside of the grouping symbols gets evaluated first. So we have 3 minus 1. So this is 4 times 3 minus 1. So we see grouping symbols. Python sees grouping symbols, so it has to evaluate what's inside first. So we have 3 minus 1, which is 2, and then 4 times 2. Okay. So these are all expressions. We can also well, let's just list out the various operators, and then we'll move on to the function part. I want to show you how we can use functions inside of an expression as well. Function calls. Alright. So let's talk about operators. What operators do we have in Python? So the most common we just talked about is the single equals operator, which is the assignment operator. Alright, and then here's some examples of the assignment operator in action. Okay, so here this is a snake case identifier. This is a variable name. I'm setting that equal to this literal data, which is blue. So that's storing something inside of color name. If we go to the terminal, I can say color name equals blue. Now when I print out color name, it prints out what's stored in this variable. Notice I didn't have any quotes around color name because color name is an identifier, it's not a string. What is stored inside of that variable is string data. Okay, so string data always has quotes around it. Identifiers do not have quotes around it. Okay, print is an identifier that points to the print function, and this is a function call. Okay, so print is a built-in identifier in Python. So you can't use, you're not supposed to use print in Python because it's already reserved. It's already used as a name in Python. Alright, so color name, color underscore name equals blue. Here's snack price. You might make a program that's going to calculate the price or the tax of something or the total price. So you can say snack price, that's our identifier, and we're going to say the snack is $2.99. If I print out snack price, I see it's $2.99. I can have number of items. Let's say I bought 3. Right? So here is another assignment statement, and this is more complex, but we're using an expression. This is an expression that contains variable data instead of literal data. This expression contains no literal data. Okay, if I had typed in $2.99 here times the number 3, that would be 2 pieces of literal data, but instead I'm using the identifiers for the variables. So there's no literal data here, this is variable data. Total equals snack price times number of items. Print total. Okay. $8.97. Alright. So this first one we're using string data, which string data is just a string of characters. And we learned about the Ascii character encoding, which is the most common and one of the most simple character encodings. Alright, here we're using floating point decimal data. There's a decimal in here, okay? And on this one we just use integer data. Okay, there's no decimal. Integers are the set of numbers 0, 1, 2, 3, 4, 5, 6 all the way up to infinity, and the negative numbers, -1, -2, -3 all the way to negative infinity. Okay, Python is really good at dealing with large numbers, and you don't usually have to specify anything special when dealing with very, very large numbers in Python. But when you think about what's actually happening in the core of the computer, there's a computer processor that is taking in a certain amount of input and performing a calculation, and there are only so many places, digits, for that input data. So it's all binary data, and when you hear of a 32-bit processor or a 64-bit processor, it's talking about how big of a numbers you can input and output to the CPU, to and from the CPU. Okay, so for very, very large numbers that are over 64 bits, there's other ways to handle those, and Python tends to do a lot of that automatically. Alright, but the key takeaway here is the data type in this variable assignment is string data. This is float data, floating point decimal. This is integer data. Alright, and then this last type of data is called Boolean data. Alright, Boolean data is just data that is either true or false. Right? It's one or the other. It's like a binary bit. It's a 1 or a 0. Okay, so is the customer willing to purchase it? Okay, you set that equal to true. Does the customer have cash? So has cash equals false. So we have two variables here. Willing to purchase, that's true, but the customer doesn't have any cash. So this third variable, we're going to write a Boolean expression and combine these two variables. Okay. So willing to purchase is true, has cash is false, can make transaction. So in order to make the transaction, the customer has to be willing to purchase and the customer has to have cash. Okay, so we join these two things. And is a keyword in Python. It's one of the operators in Boolean logic. So when dealing with Boolean data, there are certain operators you can use. When you're dealing with string data, there are certain operators you can use. Integer and float data have arithmetic operators that you can use. Okay, so the AND operator, we'll go into that in a little bit, is one of the Boolean operators. Okay, so print. So remember, the customer was willing to purchase it, but he didn't have any cash. So can we make the purchase? No. Okay. Now, if somehow he goes back to his car and gets cash, and then we set can make transaction back to this variable and this variable. Now can he make transaction? Yes, because willing to purchase was still true, and then we changed the variable has cash to false, or from false to true. So this is true and this is true. So you can make the transaction. So that is true. Alright, so that's variable assignment. That is identifier, the equal sign, and then an expression. Okay, let's look at some other operators. Look at the string operators next. So when you have string data, remember that's a string of character data. Oh wait, there we go. So concatenation, that just means joining. So you have a string of characters and you want to concatenate them together or join them together. You can use the plus symbol in Python. Okay? Plus has a different meaning depending on the type of data you're using. So this is the type of data of the operands. Okay, so here's a couple of examples. If I have the string hello with no space and then the string there, it yields hello there. Okay, notice that there's no space. You have to be careful. That's a common mistake with strings. If you want there to be space, you have to include the white space inside of the string delimiters. Okay, these are the quotation marks. They tell Python whatever's inside of these quotation marks is part of my string data. Okay, so I have hello plus a space in this one string, and then I have the concatenation operator, and then the string there. Now in this case, this is going to yield hello there. Alright, this hash symbol is just a comment character. Python ignores it. It's for the human. So I can paste this entire thing into the Python terminal, and it's going to ignore this part of the code. It's only going to execute this. This is an expression. You have literal data as an operand, an operator, plus, it's a concatenation operator, and then literal data. And it's going to ignore this. This is a comment character. And so anything after the comment character gets ignored. So you see it combined hello and there. Now in Python, you can use double quotes or single quotes for string data. I tend to use double quotes because that's more common amongst all languages. Okay. So we have the equality operator. Okay, so that would be like does Bob equal Bob? Are these two strings the same? Alright, does Bob equal Bob? Does Alice equal Alice? Okay, notice you have to have strings around both. Okay, so this is string data. Equality operators work on all types of data. Does 5 equal 5? Does 6 equal 6? Does 6.2 equal 6.2? Does Bob equal Bob? Does true equal true? Right? So that sort of stuff. And then you also have not equal. So Bob equals Bob is going to yield true. And then we have Alice equals Alice is going to yield true. And if we have Bob equals Bob, or I'm sorry, Bob equals double equals Alice, that's going to yield false. Okay, so that's the equality operator, and it's double equals when you're checking to see if one value equals another. Okay, and it's more common to use something like a variable name. I could say name equals Bob, and then does name equal Bob. Does name equal Alice? So what's stored in name is Bob, the string data, B-O-B. Is the string data stored in name equal to the string data Alice? No, this is going to be false. Okay. Is the string data stored in name not equal to Alice? That is true. It is not equal to Alice. Okay. So not equals is checking for not equality. Another way to do that is you could say not, use grouping symbols, and say name equals Alice. Okay. Does Bob is stored in name, is that equal to the string data Alice? So this is false, and then this whole thing gets knotted or inverted, which means false becomes true. So this would yield true. Okay. So all of these equality operators, they return Boolean values. Does this thing equal that thing? Does 5 equal 6? It yields false. Alright, there's a contains operator to check to see if a string contains a certain amount of data. So here we would say name equals Jessica, and then is Jess in name. This yields true. Okay, because these characters are inside of this string. This is a substring of this larger string data. Okay, so Jess is in this larger name. Okay, does Jess equal name? That's going to yield false, because Jess is not the same as Jessica, but Jess is inside Jessica. Alright? Alright, so we've got, those are the string operators, then you've got the common numeric operators. Okay, so 3 plus 10 yields 13. 7 minus 4 yields 3. So that's addition, subtraction. You've got multiplication. 7 times 8. It's 56. Division. 14 divided by 2. Yields 7. Now this one's interesting because of division, and it's common to have a decimal. All of the results of division, even if you start with integers, this is integer data, it becomes decimal data if I did like 7.0. This is floating point decimal data. It's a different data type. It's stored differently in memory. Okay, but if I just have a 7, that's integer data. All right. So if we go into Python here and we type all of these in, 3 plus 10, 13, 7 minus 4, 3, 7 times 8, 56. Now this one, notice none of these have a decimal point. Division always changes the type and makes it a decimal, even if it divides evenly. Okay, so that's 7.0. Alright, and then the last one here, this is Modulus Operator. The Modulus Operator is the remainder after you divide. Okay, so 5 modulus 4. Well, what's 5 divided by 4? How many times does 4 go into 5? It goes in once, and then there's 1 left over, right? So there's 1 left over. That's what the Modulus Operator does. It is the remainder. Okay, so if I have 12 modulus 9. 9 goes into 12 one time, and there's 3 left over. Okay, what about 13 modulus 2? Okay, 2 goes into 13 6 times, and that's 12, and then there's 1 left over. Okay, so it's the remainder. Oops. 13 modulus 2 yields 1. Okay. Then the last set of operators we have is comparison operators, at least for numeric operators, right? So these are arithmetic operators, and up here is, this needs to be unindented. String operators, variable assignment. There we go. Alright, so we have comparison operators, and that's basically, is 5 greater than 6? That's going to yield false. Is 5 less than 6? That yields true. Is 5 greater than or equal to, well, it's 5 greater than 5, that's going to yield false. Is 5 greater than or equal to 5, that's going to be true. Greater than or equal to. So greater than or equal to, that's how you remember that. The operator itself here, there are 2 symbols for this one single operator. That's greater than or equals to, right? In mathematics, you commonly see that with a greater than sign and then a line under it, okay? But that symbol isn't readily available on the keyboard, so in computer science we use 2 symbols, greater than and then equals. So is 5 greater than or equal to 5? That is true, because 5 is equal to 5, so it is greater than or equal to. Okay, and then you have the less than or equal to is 6 less than or equal to 7. That's true. And then you also have not equals. So comparison, we did the comparisons up here, but there's also the not equals with numbers as well. So as 6, see, we can have, we're counting something, we can say count equals 6. Is count equal to 6? That yields true. And then we could say, is count not equal to 5? Well, count is 6, so count does not equal 5. 6 does not equal 5, so that also yields true. All right, those are the comparison operators. And then we'll go, the last section here is comparison operators, or I'm sorry, Boolean operators. So the different types of data matter. Okay, so here we're using Boolean operators. That's for Boolean data. Alright, up here, numeric operators. That's for numeric data. And that can be integer data or floating point decimal data. Alright, and then up here, these are the specific operators for string data. Alright, so the type of data is very important as we go through all of this in computer science. Alright, so Boolean data, as we said before, Boolean data is a true or a false. It's one of two values. It's either a 0 or a 1. Okay, think of that, that's how it's actually stored in the computer, with a 0 or with a 1. Alright, so we have a Boolean operator. That's how do you compare a 0 or a 1? It seems like there's not much you can do. However, there is actually a whole lot of Boolean logic that you can do. Okay, so first you can check for equality. Is false equal to false? Yes, that's true. Is 0 equal to 0? Yes, that's true. Is false equal to true? No, that's not true. That's false. Is true equal to false? No, that's not true. Is true equal to true? Yes. So that's just basic equality, and then you can do the not equals as well, which basically inverts all of these. Alright. The AND operator. This is similar to our demonstration up here when we did can makes the transaction. It takes two Boolean variables and joins them. If both of them are true, that's the only way this variable can be true. If this is true and also this is true, that makes this whole expression true. So then we're setting this value of true to this variable with the assignment statement. Okay, so that's the AND statement. False and false yields false. False and true yields false. True and false yields false. The only way you can yield a true is if both items are true. This and that is true. Okay. Now the OR operator is similar but different. Okay. OR means if one or the other is true, it's true. Okay, so if they're both false, that's the only way you can have a false with OR. If this thing is false or that thing is false, then you have a false. Is this item blue or green? Okay, if the item is red, it is neither blue nor is it green. So that's false. Okay, is the item blue or red? Well, yes, it's one of those two. The item is red, so that yields true. Okay, is the item red or green? Yields true. It's red. Okay, is this item red or round? And maybe it's a round red ball. Okay, that would be true. Okay, so this is Boolean logic. It seems like there wouldn't be a lot you can do with just a data type that can be either a 0 or a 1, or rather a true or a false, but it turns out there's quite a bit you can do with Boolean logic. All right, and you use it a lot in computer science. Okay, so the Boolean logic part is very important. You may have seen this in other mathematics courses, but it's going to be critically important for conditional statements and looping and all the somewhat advanced stuff in computer science. All right, so AND and OR are critical. They have two operands, right? That's an operand, and that's an operand, and then the AND is the operator. Okay, so this operator, just like in mathematics you have a plus sign, this operator, instead of just being one symbol, it's 3 in Python. Okay, and then we have the not operator. Okay, and in Python that's just the not keyword. Okay, so if I have false and I put a not in front of it, that turns it to the opposite. It makes it not false is true. Not true is false. Okay, you can combine these in lots of different ways and get different results. Okay, so that should be enough for this initial video on statements and expressions. Okay, so it's important to know something about data types. We'll go more into the basic data types going forward, but here we have a listing of all of the different operators, or most of the different operators for the different types of data, right? And the most common statement in computer science is probably the assignment statement, where you assign a value to a variable. So there's an identifier, an equals sign, which is the operator, and then the expression that evaluates down to a single value. Okay.